Good morning, everybody. I am Chiranthan from Information Science Department in Intermediate Institute of Technology. Today, my project is automatic number plate recognition, which is used in various domains of technology and even real life situations, such as government uses like toll, and even it can be used in colleges and schools to recognize number plates and add it to their registries. So here I downloaded the dataset, training dataset from a website called RoboFlow. It's a similar dataset providing hub just like Kaggle. So first, we need to import Torch because we'll be using two models in this whole project, which is one is YOLO. YOLO is used to crop the whole car image and convert it into the number plate format, which is when we use the YOLO model on the training image, we'll get the number plate, just the number plate image. Then we can pass it to OCR, which is another model, which will actually read the number plate and will print it. And the number plate data can be added to the registry. So first, we will be importing Torch. Then both Torch GPU and CPU can be used for this project, and we'll be importing YOLO. Then RoboFlow is used for importing the dataset. So after importing the dataset, I'm using a YOLO 8 small model. So actually, it depends on the project. We could have even used big models or medium models, but for image, YOLO is already great in recognizing and cropping images. So using nano and small models for these datasets are actually pretty good, as they'll have comparatively less parameters than YOLO big and large, which contains millions of parameters, so which will take a lot of resources for converting the YOLO thing. So now after training, okay, in the training dataset, training we have used HippoCast 50. That means it will be trained for 50 times the same dataset, and also we know that every CNN model takes same x to x pixel ratio. So we'll be converting the whole image into 640 into 640 pixels. Then we'll be using 8 images batch size. Then uh, next, after the training we'll be comparing with the testing model if the model is working properly or not. We got the best model in my fifth training, so we'll be using that best model and getting when we get the scores, evaluation scores, we'll have that MAP as 0.98, which is actually a very great score. Precision and recall is also 0.99, but this can vary because in real world there can be different situations like angle of the detection of the car image or car video, and even the blurriness or the weather could affect the image or video quality. So this can be varied. So one thing is show that 0.95 is like minimum for this model. Seeing this code, I have plotted some graphs. One is the F1 score is confidence graph, so which shows us which is nearly one, and which is nearly one, which makes this model a very great model to recognize these Euro plates. So this is also precedence confidence graph. This is also almost one. So this also says that this model is suitable for detection. Even the precision recall curve is almost perfect. That's because as we know, precision says if it's the number plate or not. So when YOLO converts a normal image to number plate, it almost crops out everything and just preserves the number plate. So this happens every time, as it's already been in YOLO, as YOLO has been trained from a lot of trained for a lot of data. So this is expected. We'll get 0.99 from YOLO. Even the recoil confidence graph is around 0.9, which is also a very great score. So now this part of the code is to convert a YOLO into cropped images, which will be storing in other folder. So then we'll be using that folder to detect, pass into OCR to detect the number plate. Now I'll be importing OS and CV2. To use a video format. First, this is the code to crop the image and store it into a new data, which is OCR data, which you can see here. So now uh, this is extra data set which we if we want to train and enhance the model, we can use this data set, but currently it's not required, so I'll be skipping this part. So now for OCR, there's a thing called Paddle. Paddle Paddle has OCR models, so we'll be using that OCR model. There's no need of training required for this particular OCR model, as this can easily detect any number plate because it's been trained across millions and billions of data, so it's very accurate here. So we'll be using that model, and I'll show you an example how it will represent it. So first, this is the original image, which will be captured from a camera or cropped from a video. This is the YOLO's work. YOLO crops it into just the number plate. Then the OCR model converts the number plate into its text, which you can see it here. Also, I have another example which we'll be trying here. Uh, as you can also see, this has also been converted into number plate, and then it has been decoded. So as it's the time taken on converting actually depends on the backend processor. If you have a very good GPU, it will take very less time, and that will help us. So now so what we did till now is just converting image into text. So now if you have to convert a video, which is if you consider a situation where you're having CCTV data, so you have to convert that data into this text. So what we are doing is will be as you know, normally the CCTV video is between 24 to 30 fps. So we'll check every 60 fps and if, and convert it into a data as it's just running on CPU. But in real, the deployed model, it will be running every 2 frames per second, as we need to check for duplicates, and even check if, I mean, even we have to check if two values are like matching or not. So I have considered 60 frames per second here. So I'll be running this, and I'll be showing you trial data. Detect an image from the internet. So you guys can see there's a car image from the internet. So if I enable the, so now when I this is the camera model which I'm using to replicate my webcam. So here, this part of the code will actually you can also check this on a website. So what we'll do is I have implemented the same thing in React. So the React handles all the front end, back end and stuff. So what happens is the fast API actually converts the data provided because from the image due to this model YOLA and OCR model, and sends it to the backend. The backend is connected through Vercel through a tunnel which will be initiated by ngrok. So all the three terminals are running in my base computer. So we'll be checking if the website will be able to. Okay, this is the interface of the website. So we'll start from initial stage. This is just to demonstrate the model, how can it be applied in real life. So here, to show the camera, we'll be using my webcam, which is this. Then I have also integrated Google login to what to increase the security and stuff. So here you can see the camera. So now, for example, I'll just put it here, and the model starts scanning. So the model is trying to scan it, so it scanned it. So you can see the number plate here, which is the same as the car. So what happens is, we can see sometimes the model makes mistakes. It can also read this number plate as HH14MC8285. To actually eliminate those possibilities, what I've done is, we'll be considering the number plate only if two consecutive predictions are correct. So here, to this number to be correct in the backend, actually it has to be processed twice. So if it's processed twice, then this number plate will be added to it. Also, to increase the accuracy, we can also make it into three consecutive times. Also, to demonstrate again, we'll be using another car's data here. As you can see, the number plate is detected here too. So, and also here we can see some error, or it can take some time, because this the camera is not stable. But in real life, like if you consider CCTV footage, it will be very stable. So if a car slows down, it will capture it properly. And if you have a graphic card setup too, it will capture properly. This is another example which we'll try and show. I'm using three examples just to demonstrate three different states related to. Actually, we can also update this model by using adding the history and even downloading the session, which will actually convert the models, the car number plate, the date, time, and convert it to a text file. So actually, this was under implementation, but React failed to provide this thing, as I'm not a front-end developer. So it can be also updated by training more data and making it more accurate, and even using higher end GPUs in the backend will actually we can cut down the 5 frames per second into 2 or 3 frames. That it will detect the number plate in very less time. In under a second, it can detect 2 or 3 number plates, and this model can be used in hospitals, schools, colleges, and even malls and parking lots, and wherever you want to detect number plate, or have a registry of the vehicles which are accessing the area. So this is it. This is my caption project. Thank you.